I'm Sarthak, the CEO and founder at Nanonets, and I'm going to be talking to you about successful and failed AI projects. So you've probably seen this report there, 95% of generative AI pilots are failing. So hopefully we can just all head back home now. And we have a good excuse as to why the projects don't need to be deployed. But there's a fairly famous article that came out in 1903 in the New York Times that said it might take anywhere between 1 to 10 million years to develop airplanes. And estimates are sometimes wrong, but this was wrong maybe between 5 to 50 million times, and 9 weeks later, the Wright brothers had the first flight. So we're kind of in that AI moment today. And I'm going to talk to you about our experience building AI projects and deploying them in some of the enterprises that you have heard of. We serve 100,000 self-serve customers, and we've done 1,000 plus AI implementations. So we're at the sort of inflection point where there is a lot of experimentation, but the success rates are on the lower end. This is, I'm not sure it's 5%, but it's definitely on the lower end. It doesn't mean we should stop experimenting, and I'm going to try to make a case for why. It's one of the classic innovator's dilemma where you have an existing business, product, technology that's working, and there is a potential to get incrementally better. BlackBerry was trying to make a better keyboard because that's what their customers were asking for. Their most demanding customers kept asking for a better keyboard, but the disruption came from the touchscreen. And we're sort of at the point where the technology is so good that it can lead to the next level of disruption if the incumbents just keep iterating on what they've been doing before. Here is from the 1950s, this is played out over and over again, where disruptive technology has come and wiped out entire industries. I think AI has the potential to do that again today, but it's not a phenomenon where it's not happened in the past. It's happened frequently in the past where entire industries have been wiped out. Probably some of the things I mentioned here, people may not even remember existed. So what makes an AI team or an AI project successful? All AI projects are similar, and every failed AI project has a different reason why it failed. And I'm going to try and talk to you about some of those. In terms of, before we get to what a successful AI project is, we'll just talk about what is the definition that we're using here. There was some positive end user NPS. There was a reduction or reallocation in headcount. There's a reduction in TAT or error rates, so the turnaround time or error rates, and this is what we're defining as success. The research methodology was about 120 AI projects, and we've looked at the ones that were successful, and we're going to talk about what it took for these projects to succeed. One of the consultants on our team put together this slide, and I read double-ended prioritization approach, and I thought everybody's going to fall asleep. So I have a slightly better way of trying to create maybe more memorable ways to sort of define what helps AI projects succeed. And you really need to babysit the AI. You need to think of it as an iterative approach to development, where you start with training wheels. You can't just take an AI and say, here is a bicycle, please ride it. You have to take it through the motions and plan for a 6 to 18-month journey of hand-holding a project to success. So start with something small, start with a small percentage of automation, and then spend the next 6 to 18 months trying to get it to a level of production where you can completely let the AI take over. 96% of times on airplanes are spent in autopilot, but if you've ever had the opportunity to be inside a cockpit, you know that there are maybe about 1,000 switches and 2 extremely trained, well-trained pilots. So think of AI in a very similar way. You need to design for the human to be able to take over for the percentage of time that the AI is going to fail. Don't design the AI to take over, design for human intervention and build all of the controls that would be needed for the human to intervene, as well as create intelligent sort of inputs where the human is directly asked to take control. I'll maybe let you read the Dilbert comic for a second. But the idea is put an engineer on the team, make them invested in the team's success, try getting all of the different stakeholders, people who are going to be implementing the project on the team as well, and ensure they understand the business requirements. So really put an engineer on the team and get them really invested in the success of the project. There is this equation that's running all of AI right now, and the acronym is GIGO, but it stands for garbage in, garbage out. If you take garbage square, you're just going to get worse garbage. So spending a ton of time on the data that goes into either the RAG or the training of the AI model before you even start building the AI application. So an example of this could be customer service or customer success, where people have had the most success building agents to respond to customer queries. If the knowledge base itself is outdated or it wasn't trained on the correct data, it's going to give nonsense results. And I'll give you an example of this that you can try yourself. If you open ChatGPT at any point in time, I'm sure you can ask it to build an API to use OpenAI's model. Even ChatGPT will hallucinate on OpenAI's own documentation because of how frequently they update their models. Today, maybe just now they launched Sora, so I don't know what the API is, but I'm sure ChatGPT won't give it to you. So ensuring you have correct data at every single point in time when the AI needs to respond, it has access to great data, is a part of the AI project. AI is going through this revolution, and the most successful projects are all bottoms up. If you think about any of the code writing assistants, they're individual engineers bypassing every security restriction to be able to get help in writing code. And it's a very bottoms up motion, and all of the projects that are being delivered in a bottoms up fashion are the ones that are succeeding. You don't need a CIO to push an AI agenda. You want citizen developers who come in and find AI applications in their day-to-day, and they are the ones who sit and solve these problems. That's the thing that's really working. There is this assumption that AI is going to come in and replace jobs. We're actually seeing the reverse, which is people are quitting their jobs to become full-time TikTok streamers because they hate how mundane and boring their jobs are. And if you don't bring in AI innovation, people are just going to end up doing other things because of how boring they find their day jobs. Things that don't really matter. So we talked about some of the things that matter, but what are the things that don't matter? If you pick a project that is in a cost center or a revenue center, makes absolutely no difference. A lot of you may be worried about what is the level of technical expertise that is required to champion an AI project. And what we've seen is that has no correlation to the success. Somebody completely non-technical can also champion an AI project. Budgets don't particularly matter, especially when you think of it grounds up. You don't need to be thinking about what is the budget when all of it scales. You really need to be worried about what's the cost of experimentation, which is really low. Formal POCs or CXOs getting involved, again, doesn't correlate to success. Small iterations, testing, small experiments at the ground level is really what is succeeding. So what is a successful AI champions playbook? I'm sure you guys want to all go back and try AI applications if you're not already doing it. So I'll take an example of one of our customers that's a few $100 billion company in the IT industry. And it's the first thing is find a wow moment. You really need to capture the imagination of the people you're demoing to. They need to feel the experience, and you really need to create a wow moment. All of the AI demos that are winning have a wow moment that captures the imagination. I know I'm using slides, but please don't when you do your AI demos. They tend not to work, and actual demos tell the story much better. You also need to spend time finding technologies that work, which is even though there are AI APIs that claim to be a Swiss Army knife that solve all problems, you really need to find the AI application or the AI technology that works for you, given every model is not created equal. Some might have better latency, some might have better accuracy, and you really need to figure out what the right trade-off is and what the right selection is. You may not need to invest time on this yourself, but there's definitely somebody on the team who needs to spend time finding the right technology. And it needs to be a goal-based iteration. You need to find out what the small win is, deliver the win, and then iterate on it. So here is an example of what we did. The wow moment was an automatic correction of errors where we created the experience of the AI learning instantly when a human made a correction. This is in a data extraction use case. So a correction happening automatically helped the model learn and delivered the results in the next iteration. We did a live demo with 10 sample documents and an SAP integration where data was shown going from a document directly into SAP. We used a small trainable language model as opposed to a large model because latency and response time were critical in this case. And we did 5 iterations over 3 months to get a high confidence score. One of the things that was really important was confidence score so that people knew when to kick out something to a person for manual review. And this would basically be a playbook for conducting a successful POC or conducting a successful AI pilot that you might want to do yourself. We're at booth 110, so you can come find us. We're happy to share more information on some of the projects that we've done and what else that we do. And I'm happy to take any questions if there's time. Sure, please go ahead.
Tell us about the name of your company.
Yeah, so the idea behind the name is we build small trainable models and that can be fine-tuned per customer. That's the reason for the name. Yeah, we actually predated the large language models, so we were forced to start with small trainable models, but no, I think building models that are fine-tunable on specific data is important. When you look at really large language models, RAG is probably one of the best ways to inject data into them, but if you really want to fine-tune a large model, it becomes very cumbersome, especially when you want to do it per use case. So specific, like I don't want to say that there is a cookie cutter, one single approach to solving all of these problems, but for specifically the kinds of problems that we solve, which is converting unstructured into structured data and then automating a workflow, we see that these small language models work much better than the large language models. Yeah, please. We actually have launched our models on Hugging Face, but we have a SaaS offering, so that has proprietary models. We keep launching open source models on Hugging Face as well. I think up until the most recent Grok version was released, we were the #1 model on Hugging Face for about 2 months. Yeah, sorry, please.
Those models industry specific or
Yeah. Vertical specialization hasn't really helped in these models, and training them on generic data is generally significantly better or leads to better results. But fine tuning on a particular customer's use cases is more beneficial than fine tuning on an industry data set. So if you were looking at radiology, you would still be better off training a large model on all kinds of images and then just fine tuning on only radiology images as opposed to all images that might come from a medical domain.
you do fine tuning for each of them?
That's correct. And for every single application, and we deliver that at the speed of, you could get a fine-tuned model in a couple of minutes.
Like a mechanism in place to distinguish when to use small language models as opposed to large language models. I've seen like decision week where it allows you to, for different use cases, take a specific small model. Is that something that's linked to you, or is there only once they choose a small model that's?
Yeah. I think a great implementation of this is, again, what OpenAI has done in front of GPT-5, where they've added a router. What we do is, when we fine-tuned a model for a customer, at that time, depending on the application, we're selecting a model. So there is less chance of a change later on. But at the time of training, we are selecting between about 200 different models and architectures to select the right one for you. So it could be a large model, it could be a small model, just depending on the various constraints that exist. But I think there's a lot of different types of solutions to that specific problem. Okay, thank you so much for taking the time to listen to me.